These are questions that appear in the textbook as examples. Again, I'm going to use the textbook as more of a resource for questions. The way they explain things, I'm not a big fan. Okay? So I will also provide like the example questions for you. But when it comes time to doing them, then you'll have to pull them out of the book, right? So let's do a few here. I'm going to stop when I get to what I know refer to as the Fred and Barney style question. Oh, here it is here. And you'll see that tomorrow.
Fred and Barney.
Yeah, Fred and Barney. Okay, so we're going to do the first 11, I think. Sorry, for 7 to 11. Okay, so just a reminder, here are the formulas that we have so far. They are V bar equals D over T.
That's pretty.
A equals delta V over delta T. It looks like there's missing some things here. VF equals VI plus AT. D equals VIT plus a half AT squared. VF squared equals VI squared plus 2AD. And our old friend, quadratic formula, minus B plus or minus the square root of B squared minus 4AC all over 2A. Those are the things you're going to need to know, or to be able to use, I guess, your tools, your toolkit. So Kitty O'Neill, who's a real person, was or is, I don't know if she's alive or not, a female dragster. She reached a speed of 628 kilometers per hour from rest, 3.72 seconds in that car. How far did she travel? Want to take a guess? Probably pretty far. Okay, so what do we know? We know that her initial speed was 0. We know that her final speed was at 628, and it's in kilometers per hour, and our time is 3.72, right? Do you feel like we should convert the 628 kilometers per hour?
Yeah.
Do you feel like that should be converted to meters per second?
Yeah.
Seems like it, doesn't it? So 628, we're going to divide by 2.6, and we're going to get 174.4. Yeah, we'll just round it. 3.6. 628 divided by 3.6, or 174.4 meters per second. Wow. That's a lot of meters. We need to know how far. We're solving for the displacement, the D. Which one has D? I guess this is VI. We don't have the acceleration, do we? No, we don't. So we're going to have to determine because all the formulas that have D in them have A. So we're going to have to find acceleration. VF equals VI plus AT. Final velocity, 174.4. Initial is 0. Acceleration, is what we're solving for. And our time is 3. So really, the acceleration is just 174.4 divided by 3.72, or 46.9. Meters per second squared. That is major league acceleration. You know what G's are?
Yes.
What are G's? So letter that comes before each. Hey, did you know today's International Cockroach Pirate Day?
Yeah, I mean, I saw on your Facebook last night.
What's the pirate's favorite letter, Colin?
Z.
I know, you still got it wrong.
Hey.
Why are we saying those in work?
I'm kind of sad that you
We're going to fire Johnny work.
I just like that pirate joke.
Sorry, man.
Yeah.
On my Facebook thing popped up about today the International Cockroach Pirate Day. There were these two former students. One is now a teacher in Point Fly. One is now the official photographer for the Saskatchewan Rough Riders. Yeah. You will see him when you watch Rough Rider games. You will see him on the sidelines. He has long, long hair and he's all padded up. And for whatever reason, I don't know why, but they always mocked me. Always sort of like, it was like an inside joke. It was, I must have said something that reminded them of pirates, and whenever I spoke, they'd always like kind of mock me about being a pirate. I never really did figure it out. But whenever I get to the International Talker Pirate Day, I always think of those two. I don't know. I must have said something that reminded them of being I was a pirate or something. And so like they were always making pirate comments around it. But I didn't understand it. Make sense? Yeah, but they never really told me why. I guess I could. Now that they're adults, yeah, I could ask.
They probably hear a pirate joke, you know.
Oh, I think they remember, yeah.
Pirate joke?
What? Oh.
He likes a huge steering wheel sticking out of his pants.
Okay, and I walked into a bar, he has a huge steering wheel.
And then the bartender says, "Sir, do you realize you have a steering wheel in your pants?" And he says, "Arg, I know, it's driving me nuts."
I don't get it, say it again.
You'll tell you later.
You like it?
It's not bad. Can't say it's 100% too appropriate, but I will say that it's grade 12 appropriate. It's not bad. Well, all right.
It's so squeaky. I can't focus.
Oh, okay, man.
What has a what?
The tables.
All right. How the heck did I get on that topic? Oh, I was talking about G's.
Yeah.
No, you were distracted. You were like, "Oh, you guys, guess what?"
Yeah, I got distracted by, I said, do you know what a G is? Then I said it's the letter F before H, and then I thought about letters and the C, and and here we are talking about, whatever. Okay, so we got our acceleration. So we want to know the displacement, D. Okay, Johnny, I've allowed that to happen for a couple minutes, hoping upon hope that you'll just stop, but you haven't. So stop. D equals VIT plus 1/2 AT squared. The initial velocity is 0. That's always a good thing.
Yeah.
Plus 1/2. The acceleration is that number 46.9, and our time is 3.72 squared. This isn't a particularly challenging question, is it?
Wait, VIT.
VIT plus 1/2 AT squared, right?
Why would VIT be 0?
From rest. Right.
Okay, but what
Each
about
time it's exactly zero. Zero times whatever equals.
Oh, well, yeah, exactly. I didn't miss it. I just went 0 velocity times time.
Oh.
I did the multiplication ahead of time, right? I always forget that I have to explain that to you. Can I just finish this? Okay. So, I mean, you could put, let's do it first because maybe this is a little bit new to you.
Sure.
It's 0 times 3.72, but like someone over here said, because it's multiplied by 0, it drops out, right? Go ahead.
Okay, wait, what were you saying with G's?
A G is a unit of acceleration as well, so like 1 G is 9.8 meters per second squared. So as you're falling, right, you would experience 1 G, 9.8. So 2 G's would be like almost 20, right? So that's like 46.9, that's like 4.5 G's. That's a lot of G. Her face would be like this as she's getting accelerated. So the distance is 324, I think, 324.3 meters. So pretty far.
In 3.7 seconds.
In 3.72 seconds.
That's almost 100 meters.
That's like almost a quarter mile. You're not getting that answer?
I'm getting 30. I'm getting 649. I'm getting 30.
You're doing something wrong.
That's what I got.
Square it, right?
You got to square that T.
Yeah, I got, and then you times it by 1,000.
46.9 times by a half.
Okay, well, that was a times by half. You square 3.7.
The 3.72 is squared, yeah? You can on your calculator, you can just type it in order. You can go 1/2, 25 times 46.9 times 3.72 squared equals. Make sure you hit equals. Okay, here's example number 8. We have a Ferrari moving at 20 kilometers an hour. It's going to 230 kilometers an hour in 7.5 seconds. As it does so, it covers an unknown distance. Find the distance covered. I think this seems to be very similar. what do we have here? We have an initial velocity.
0.
We have a final velocity. Again, we have a time. And we're solving for d. The only difference here is we have a VI. Now, okay. Should I change both of those to meters per second?
Yes.
Or can I do the subtraction and then change the change? Change the change.
I'm just
You can-
beforehand.
Yep, absolutely. If you want to do it beforehand, let's do that. Nope. Nope. And if you want, I can go and show you the math of y. So that's going to be 20 divided by 3.6. It's just that it takes a little bit longer. 5.6. 230 divided by 3.6, or 63.9. So 63.9 is equal to 5.6 times a. This time the acceleration is quite a bit less, isn't it? All right? It's happening in 7.5 seconds. After all, it's only a Ferrari. 63.9 minus 5.6 all over 7.5, right? This is 260 meters. Oh, no, hang on. Acceleration, 7.77.
Oh, that was a 7. I thought that was a question.
Here? That's a 7.5.
What is that?
7.
7.77. Meters per second squared. No dragster. Now we're going to go d equals VIT plus a half AT squared. Initial velocity. Now, should I use the 20? No, because the acceleration is in meters per second squared, so I need to use the 5.6. Now, here's where you got to write it out, right? Because it's not 0. Is that you, Ty? Every time I look down, I hear that noise. And I look up and see who's doing it, and they're not doing it. Okay, so we got 5.6 times 7.5 plus a half times 7.77 times 7.5 squared. And you should be able to do that all in one big giant step on your calculator.
Why?
Well, why not?
Because if you mess up, then you're dead.
It's just one less
I
than
bet it's 60.5.
Pretty close. I probably did some rounding somewhere.
Yeah, you got the answer wrong.
As long as you guys know this, as long as I see the process, no problem, right? Okay. Calculate the acceleration of an airbag if it deploys in 30 milliseconds and moves out a distance of 40 centimeters.
milliseconds.
Not done, Josh?
Why?
Centi means hundredth. How many cents in a dollar? A cent is 1/100th of a dollar, so 40 divided by 100 is the displacement, which is going to be 0.4 meters. Did you just say, how am I supposed to know that?
No, you're
Did you not learn the metric system like about grade 4? Get used to it. Right? 40 divided by 100. So that's going to be 0.4, I guess, or 0.4 0 meters. We want to know the acceleration. We're solving for A. Which one has A, T, and A in it? Or I guess this is the D, right?
The one that they're both square.
We're missing one.
It's okay.
You're saying the initial 0.
Yeah.
Okay? Now, is the initial... I need to take away something. You're so distracted. It's unbelievable. Pay attention. It's going to get so much harder, you guys. So much harder. Even if the car is driving at 100 kilometers an hour, is the initial velocity 0?
Yes.
How come?
Because it's not in motion.
In relation or relative to the car itself. That's right. Or the person inside it. So the initial velocity is 0. So we're going to use d equals VIT plus 1/2 AT squared. Initial velocity is 0. Multiplied by the time is 0. Plus 1/2 our acceleration, which, well, we're finding the acceleration.
Yeah.
And we know the distance. Oh, here we go. So that's going to be 0.4. And our time is 0.03 squared. Okay, now how should I go about solving this? Okay. Can we do more than that in the first step? How about we leave the 0.4. We're going to take half of, we're going to take 0.03 squared and then take half of that, right? Go ahead and tell me what that. 0.03 squared is going to be 0.0009 times a half. I think it's 0.00. Is it 0.0045? 3 zeros?
What?
0.5 times 0.03 squared is equal to 0.00045. Yes, Talia?
Wait, isn't it? Can we use another
Can
one?
you do that again?
On your calculator.
That did not do
0.5 times 0.03 squared.
I was missing a 0 on my phone.
All right, now we're going to take our 0.4 and divide by that number, right? So 0.4 all over 0.00045.
Hey, equals.
And equals, right. And you get 888.9, we'll round it, 888.9 meters per second squared. That's the rate of acceleration of the airbag. That is fast. That's why you don't put your feet up.
Or if you get crashed.
It's a lot of G's. Golly gee, that's a lot of G's. Okay, last one.
Can't vandalize James Bond like that.
This is James Bond's lesser known sister, Jane. I'm just going by what the textbook has. Jane Bond runs down the sidewalk, accelerating uniformly at a rate of 0.2 meters per second squared from her initial velocity of 3. How long will it take Jane to travel a distance of 12 meters? This is her acceleration. That's the VI is 3. How long will it take? We're solving for time. And the distance is 12, right? So which one has those? These aren't challenging. What's so hard about these?
I don't know.
They don't want to work.
Call it the last one.
D equals VIT plus 1/2 AT squared. The displacement is 12. The initial velocity is 3. Oh, I know what's so hard about this. Oh, do you know what's coming? No?
Can you still use this formula?
The acceleration is 0.2 t squared, and you're going to get a formula that's got t and t squared in it. Or sorry, you're going to get an equation with t and t squared in it. I got 12 is equal to 3t plus 1/2. Well, I guess I could do this, right? I could go 12 is equal to 3t. A half of 0.2 squared is going to be 0.1 t squared, right? But how do you solve that? Divide out t? No, you can't add t's and t squareds together. Fact? Oh, you want to factor it? Are you sure?
Yes. I would find so many other alternatives.
Oh, well, what is the alternative to factoring?
I don't remember.
The quadratic formula. So we're going to write this as, and nobody likes it as negative, so we're going to write 0 is equal to, and the quadratic formula works when it's ax squared plus bx plus c. So the x squared is the t squared, so that's going to be 0.1 t squared plus 3t. I'm just doing what? It's going to be right away. I just flip those around, and then that 12 goes to the other side and becomes minus 12, right? And now, in the quadratic formula, the a is 0.1, the b is 3, and the c is minus 12. Ax squared plus bx plus c, but instead of x and x squared, it's t and t squared, right?
You haven't put it in the formula.
I haven't put it in the formula yet.
I thought you
No.
said that you did not.
No, I'm going to. So the quadratic formula is x is equal to minus b plus or minus the square root b squared minus 4ac all over 2a minus 3, right? No. B squared is going to be 3 squared minus 4. A is 0.1. C is minus 12. Now, do you have to be really careful with your negatives here?
Mm-hmm.
Very much so.
Does 3 have to be negative?
It's minus b. So b is plus 3, so, right? All over 2a, so that's going to be 2 times 0.1. Now, the quadratic formula should give you 2 answers. We'll get there. So we're going to have to go minus 3. Now, you guys know this. I heard you say the word. What's the word for the number underneath the square root sign? Was it you, Danielle, that knew it? The discriminant. The discriminant. If it's positive, there's 2 answers. If it's 0, there's 1. If it's negative, there's none. Okay, so this is going to be minus 3 plus or minus. So 3 squared is going to be 9. And that's minus 4, right? Yeah. So let's think about this here. Minus 4 times minus 12. Positive 48 times 0.1 is 4.8. So it's a positive value. So that tells us the discriminant's positive. That tells us there's 2. 2 times 0.1 is 0.2, right? How do you handle this plus or negative thing? Well, you got to do both. So we're going to have to find 9 plus 4.8. 9 plus 4.8, of course, is 13.8. Did I make a mistake, Marvin? 2 times 0.1 and then becomes 0.2.
It looks like 2 times.
Oh, yeah, no, that's a decimal. Good eye, Mervin. Okay, so this is going to be, now I take that, so this is going to be negative 3 plus or minus 3.7, we'll say, all over 0.2, right? I took 9 plus 4.8 and got 13.8, and then I took the square root. So you have to go minus 3 plus 3.7 over 0.2, and minus 3 minus 3.7 all over 0.2. So that's going to give you 0.7 over 2, which is 3.5 seconds. Or minus 3 minus 3.7, that's minus 6.7 divided by 0.2 is negative 33.5 seconds. Can you have negative 33.5 seconds? No. So in this case, the quadratic formula gives you what's called an extraneous root or a nonsensical root. Doesn't fit the situation.
Holy crap.
Right? So that one's a bit more challenging.
I did not like that one.
No. No, I'll have to make a mental note not to make every question like that.
You do that.
Already done, don't worry. All right. Tomorrow, bring your textbooks because tomorrow, Fred and Barney are going to be driving their cars together. We're going to have to find out when they fly. I've got 2 example questions for you tomorrow. If you didn't do any work on Friday, or on the weekend, or Monday, you should be doing some problems. I'm assuming you're doing problems kind of every day a little bit. If you're putting it off to the end, I would stop that.
I think that's actually